Okay, welcome. Let us continue with our part 2 of longitudes and latitudes. So we are talking of distances along a great circle. Distances along great circles. So we discussed and said that points which lie on the same longitude form great circles. Points which lie on the same longitude form great circles. So if this one is our prime meridian here, we can have an example. And then we have the equator marked 0 degrees. Equator. Then we have another longitude towards the left of the prime meridian. Let's call it 15 degrees, and this one will be 15 degrees west. So I can talk over latitude up here as 30 degrees north, and another latitude down the southern hemisphere, that is at 60 degrees south. So if we have a point, we call it point P, and another point down here as point Q. The location of P, as what we discussed the other day, the location of P, we start with the latitude. So latitude 30 degrees north, so we talk of 30 degrees north, comma, but on the same longitude, 15 degrees west. And then the location of Q will be latitude, this one here, which runs from left to right, 60 degrees south, comma, and longitude 15 degrees west, the same longitude. So how are we going to get the distance from P to Q? So the distance is given by the length of an arc. These two terms are subtending. So if this one is the center of the earth where the equator and the prime meridian meet, we are to look for this distance here. The distance from this point all the way to this point. So if that is the case, this is what we are going to have. Like this. This is what we are going to have. And here we have the center where the prime meridian and the equator intersect. So you have to ask yourself, if this point here up here is 30 degrees north, then this particular angle from the equator up to this point, we are going to have 30 degrees. And then if down here we have 60 degrees south, the angle from this point down here will be 60 degrees. So if that is the case, then you'll come here and say this is our point P, and this one is down here is our point, we call it point Q. The angle here was 30 degrees and down here 60 degrees. So the sum of these angles subtended at the center, we're going to have the 30 and 60. This will give us a total angle of 60 degrees plus 30 degrees. So if we take 60 degrees plus 30 degrees, we are going to end up with 90 degrees. So this is the angle theta the arc is subtending from the center. So the length or the distance from P to Q is the same as the length of an arc. And the formula to calculate the length of an arc of a circle, because the earth is a sphere, it is given by the formula degrees or the theta over 360 and then 2 pi r. Our assumption here is that the r is the radius of the earth, and it is taken to be 6,370 kilometers, unless otherwise stated. So for that case, if you want to calculate the distance from P to Q, you will realize that this theta, it is what is called the latitude difference. Latitude difference. And as far as this latitude difference is concerned, we focus mainly on the direction. If we are talking of different direction, the theta will be given by the sum if those towns lie on different directions or different hemisphere, different directions. For instance, in this case of ours, we had P, which was 30 degrees north, and Q, 60 degrees south. Both of them lie on the same longitude 15 degrees west, and we discussed that if towns lie on the same longitude, they form great circles. So this one is a great circle. We're not going to use this one. This one is just here to tell us that what we are going to use is a formula for great circle. So that particular case, this theta will be given by the sum of the individual latitudes if the direction is very different, and the same theta will be given by difference, that is subtraction, difference if we are dealing with the same direction. Same direction. So in this case of ours, the theta will be a sum of 60 and 30, which will give us 90. So for the distance PQ, in kilometers, that is, it will be distance is equivalent to the theta, in this case is 90 out of 360. We multiply by 2, then we multiply by pi is 22 out of 7, and the radius of the earth is 6,370 kilometers. So if we multiply the numerator, 90 times 2 times 22 times 6370, we are going to have 25,225,000 and then 200 kilometers. We divide by the denominator, 360 times 7, we are going to have 2,520. So if we divide, we are going to end up with a distance of 10,010 kilometers. This one will be a distance PQ. So that is how we calculate distances along great circles. The distance PQ will be 10,010 kilometers. Let us have another example. So for the other example, let us have towns, call them two towns X and Y. Point X is such that its position is 45 degrees north, 30 degrees east. And another one called Y, its position is 30 degrees north, 30 degrees east. So we have to calculate the distance, and we call it distance X, Y in kilometers. We are given R as 6,370 kilometers as the radius of the earth. So in this case, we can just have a sketch of what is happening here, even though it is not necessary, but we can just have it here. That this one is the prime meridian and we have the equator. So we're being told that they all lie at longitude 30 degrees east. So east is towards the right of the prime meridian. So this is the longitude here. Longitude of interest as 30 degrees east. We are also being told that one is at 45 degrees north and the other one is at 30. So we start with the 30 degrees and then we move up because they keep on increasing as we move upwards. So this one is 30 degrees north. The other one is 45 degrees north. So for that case, this town which is at 45 degrees north, it is called town X, and the other one which is at 30 degrees north, it is called town Y. So because they lie on the same longitude, they are going to form great circle. For that case, if you are going to calculate the distance in kilometers, you'll come here and say, let me get the latitude difference because I need to have it. So this latitude difference, we consider the latitude of X 45 degrees north and the latitude of Y 30 degrees north. Because both of them are on the same direction, that is on the same hemisphere, northern hemisphere, then the latitude difference will be given by the subtraction. So if it is subtraction, we're going to talk of 45 degrees minus 30 degrees. So 45 degrees minus 30 degrees, we are going to end up with 15 degrees. This brings us to the formula that distance xy will be given by theta over 360 2 pi r, like that, in kilometers. So our theta will be the latitude difference here, which is 15. We indicate it here, 15. All this over 360, and then times 2. Our pi will be 22 out of 7, and r is the radius of the eye, which is 6,370 kilometers. So at this point, if we take 15 times 2 times 22 times 6,370, we are going to end up with 4,204,200. And then we divide by the denominator here will be 360 times 7, which is 2,520. So if we do the long division, or if we divide, we are going to end up with 1,668 and 1/3 kilometers, and 1/3 kilometers. So this one will be the distance xy.